Welcome to the challenge of the capacitor construction. We're team number 2, and our team is made by Alfonso Nava, that is me, Marta Peñalosa, Ángel Gabriel, and Karen Harumi.
This challenge consists of building a capacitor model using an equivalent circuit, using materials that we find in our house. The objective of this challenge is to analyze the loading and unloading time for this supercapacitor.
The materials we use to build our capacitor are 2 sheets of aluminum foil of 20 per 26 centimeters, 3 sheets of wax paper, copper cables, alligator clips, and adhesive tape.
Well, for the process, first we cut 2 sheets of aluminum foil and being very carefully not to grease the aluminum too much. And then we align the aluminum foil with the sheets of wax paper and we fasten it with a little bit of adhesive tape. Then we repeat the process for the 2 sheets of aluminum and we make small holes on the wax paper. We will introduce the tip of a wire that we have previously striped, and then we roll up the different layers and adjust it with a little bit of adhesive tape. And for an extra pressure on the layers, we just apply a little bit of elastic bands to tie the paper. That's all the process.
And for the modeling on MATLAB, we first put all the constants that we had, for example, epsilon 0, the volts that the difference of potential that we were gonna use, and the areas of the conductors, and of course the distance between the conductors of where the dielectric is gonna be. And we only put the equation for calculating the capacitance, and after that we calculate the charge on MATLAB, and these were the results.
And as we can see, we obtained in MATLAB 1.7 microfarad in capacitor and charge of 5.11 and in the multimeter we obtained 11.1 microfarads.
Okay, as conclusions, we can see in the images that the multimeter gave us a resulting capacitance of 11.1 microfarads. And there are several reasons why your capacitor has given such a result, and not like in MATLAB. First reason could be the humidity inside the aluminum sheets and the wax paper, since as we know that the electric constant of the wax paper is 3.7 and the water is 81, which could vary indirectly the result. The other reason could be the two extra elastic bands that we use to reinforce the pressure inside the capacitor. And the other reason could be in the lowest value of the capacitance meter.
Yeah, what we want to say in this one is that, for example, maybe the multimeter, it's not capable of detecting such a low amount of farads. So the lowest value it can put it's in microfarads. And that's why we have such a difference between the MATLAB, the result, and the real result on the experiment. But I think it's the least possible explanation to this variation. And the last one, yeah. Go on.
The last reason could be the quality of the materials, of the dielectric material, because it could have a different permittivity value, and we didn't know. It's on the material.
It's like a little bit modified in such way that it like increases the permittivity of the material. And yeah, just to conclude, we want to say that it's important. We consider that it's important, the experiment, because it shows us how the materials and how these capacitors work and behave under certain conditions. And of course, these things are super applicable to engineering life. And that's why we consider it's important to do such things like this at school, so we can have experience, and one day we can say like, yeah, I know how to build one. And yeah, that's it. Thank you for everything, for your attention, and bye.